Hello, teacher. Today we're diving into a very statistical testing method from session 6.1.7 to 6.1.0. We cover handling time correlated data, multivariate tests, and non-parametric approach. We will break down into public formulas, real-world example, and application. Let's get started with 6.1.7 equivalent sample size. The main problem in classical statistics, we assume observations in data are independent, meaning the value doesn't affect the model. For example, when measuring data temperature, we treat a day and separate whether in fields like climatology or economic data often have other correlation where nearby values are similar. For instance, if today temperature is high, tomorrow may be too. This means the data has independent information leading to error if we use standard formula. With with 6.1, with the core concept, the effect sample size is the number of independent observations that provide the same amount of statistical information as the original correlated dataset, and the concept of variance, the mean, the sample mean. With two methods to use the other one AR autocorrelation with P1 the correlation between current and preferred and E to actually sample size. Example, if we have a actually sample size is 100 and the correlation between current and preferred value is 0.29. So we have the effective sample size are April 55. It means your 100 point will only worth 55 points. Method to use the correlation tab. TEE the time is take for observation to become independent. So we have an important constraint. The adjustment evaluate only when effective size are greater or equal to 30. If the sample size are less than 30 after the adjustment, the distribution depart from student table of test in the session 1.7 the sample size is attracted using an analytical formula. In this formula is only an approximation and perform reference for the large sample. But in the practical application, particularly in climate research, the late model set often present too much difficult. The sample size is typical small and the order correlation for infection estimate from the small sample is often vast downward, meaning is underestimated through degree of zero dependency. And with the concept, a table of tests in to the rest, this is the table of tests employed rather than rely on the approximate analytical formula which is still mathematical simulation to generate specialized critical value table is that sophisticated, careful autocorrelation and small sample effect. This method does not require manual computation of the effect sample size. Instead, the research simple appropriate critical value based on the relevant character of the dataset. The prostitute either computer sample and sample variant. So in the table of the column of the table, the estimate was one order relation more efficient option is step one, or the table of the sample size and with decisionable if the calculated status from the surrounding rather than the critical value option for the special especially table, then the research is justified the rejection the new hypothesis. Otherwise, the new hypothesis should not be tried. The great hoteling T-square test. The problem why the classical T-test is used to a single variable. Hoteling T-square test is used to compare the mean event variable, for example, spur with and determine whether the climates the current dedicated differ from the previous indicated is never concluding separate the temperature and precipitation. We combine them into multivariate mean factor and test them simultaneously. So we have two independent random tests, side 1 and 2. And the data must satisfy the following assumption: independent. The observation factor is right be independent and multinormality. Sample must draw from multivariate normal distribution to the estimation of the covariance matrix is denote the deviation from the respective samplement. With the T-square test status, the most important formula used to measure the distance between two vectors in the dimensional space. This formula and with decision rule after the committee is static about total square test form data is compared with the value given is printed. And that's like with the 6.1 the main widest test and the proposal in this slide in front of the screen given assumptions required for parametric tests are not always that field. In this situation, a non-parametric test is less restrictive assumption is required. Propose the main widest test is to test the new hypothesis that the two populations have the same distribution under the addition assumption that the two distributions have the same shape. This new hypothesis can be interpreted as test whether to the two populations the same central location commands expressed as in this formula, and that with function two populations had the same distribution. The key distinction, unlike parametric statement Y, tests do not require the data to follow the specific parametric form. Just as the former distribution is that required to data to follow the special distribution function from the next only require that distributional shape, and the main Y test is used as an alternative when the data is not followed a normal distribution and the abstract to the test for different in the median or in the overall distribution shape rather than in the mean. The computation produced first from the polar vector combine all observation to the two sample into the single point vector monitor ranking. Assign rank to observation in the point vector if an observation either small value is 1e defined as r required is. Step 3. Combine the sample the ranking. Computed the ranking. This is the primary test status. If the test book the rank of all observation belong to group is are submitted. And now we go to rejection rule for hypothesis. The test whether to do several different comparative rank stream status as with the critical value k for last sample. The critical value k can be approximated using the normal distribution approximated critical value if given by k approximated p in this for this formula. And to cite test rejection rule rejection this if either of the following holds, and that's either 6.1.11 permutation test. And in this problem, if the null hypothesis is true, thus if the two samples is actually come from the sample population, then whether a particular population belongs to group is or to random. Therefore, we put all observations together and randomly recite them into new group. The resulting group characteristics represent what could be observed by trend. This approach allows the assumption about the underlying distribution to be realized even further than the main in the main quadrant test. Test for you have 7 steps. And in the first step is pulling the sample, pulling all observation from sample A and E into in a single comparator to computing observed test status from the original. Number 3, either commute the data randomly, commute the data in 11th of the pulling sample to generate permutation sample. Number 4 is computer permutation status for each permutation computer status. And number 5 is compare and make a decision. If not hypothesis, it failed the observed value will lie in the streaming region, will lie to the distribution of stated option from the permutation. 6. Compare the p-value. The p-value is estimated at the proportion of permutation thus will add status more extremely than the observed one. In this, by this formula, if the value is smaller than the chosen significant level alpha, result hypothesis. In practice, about 1,000 permutation